You're going to be reviewing quadratic functions. The goal of today is hopefully refresh your memory about solving quadratic equations. Later on in the week, we'll convert between the different forms, graph, and also recognize roots of quadratic functions. So, as you notice, I accidentally went through the lesson without starting this, so I do apologize, but here you go. The first thing to solving quadratic functions, we're going to start with factoring. The first thing we got to go back over is zero product property. That's if x times y equals 0, then that means x equals 0 and y equals 0. When you apply to the factoring form, x minus a, x minus b equals 0, then you set both factors equal to 0, and that is zero product property. So let's review factoring. When a is 1, you find two numbers that multiply to give you the c, add together to give you the b. So two numbers that multiply to give you negative 14, add to give you a negative 5, that's negative 7 and positive 2. So you write in the two factors, x minus 7 and x plus 2. You set both factors equal to 0 and you solve to get x equals 7, x equals a negative 2. Over here, since a is not 1, you want to multiply the a and the c together to get a negative 15. Once you get that, you have to ask yourself, okay, well, what two numbers give you that product? So negative 15 and add together to give you the b. That's a positive 2. So we find that those two numbers are negative 3 and a positive 5. So we write those two numbers down. Then we create our fractions. You remember this? This is called the California method. So you put the a on top of both of your fractions, and then you reduce. 3x over a negative 3 is an x minus 1, and 3x over 5 does not reduce, so you get 3x plus 5, and that's equal to 0. So then from there, you set both factors equal to 0, and you get your solutions. What were your solutions? X equals 1, and x equals what? Negative 5 over 3, because you subtract 5 and then you divide by 3. Okay? Always remember, before you even start the factor, you check for greatest common factor. All right? Let's do two more. I'll let you guys do these on your own. Then we'll come back together in like 5 minutes, maybe less. Record this. And what do you guys get for x? X equals what? And over here, x equals? Like that? Yeah. Okay. Good stuff. Refreshing our memory continues to complete the square. Complete the square. You gotta remember a few steps. What's the first thing you gotta remember about completing the square? True. Well, let's to solve by completing the square. Let's do it that way. To solve by completing the square. You don't want it equal to 0 if you're solving by completing the square. Where should your constant be?
It's on the other side of the equal sign.
So it should equal your c. Okay? The whole problem should equal your c, equal your constant. Okay? And then what else do you have to be sure of before you even get started with the whole process of completing the square? A has to equal 1. Okay? So when you're solving by completing the square, you have to make sure that your constant's on the other side and A has to be 1. Then from there, what do you do?
I remember there's a bunch of...
Do something with B.
Use
Half of B, but not times 2. You have to square it. So you take half of B, and then you square it, and then whatever number you get, you add it to each side. And then
move it back over, right?
And then make sure you take the square of...
Square something.
Oh, you square like...
no, we've already squared half of
No, you
B.
take the root
Square root.
of 1, right? Of the
Then
B.
like you solve
Oh, of the new numbers.
Why would you take
Okay.
the square root
Let's
of B?
go through steps so far with this example. So does it equals the constant?
Yeah.
Yep.
Is A1.
Yep.
So we take half of B, which is
5.
because B is 10. then you square it. So then you add it to both sides. You can say that was 25? And that's usually right here is where the square is. Now what do you do?
Oh, then you add 625.
You add this to get, what do you do to the left side? You factor. Because the left side will always form a perfect square trinomial. What is this when you factor? X plus 5 times x plus 5, which is the same thing as x plus 5 squared. And then you just solve from here. How do I solve this? Square root both sides. And remember, whenever you square root, you get a positive and a negative. And then the last step? So you have negative 5 plus or minus the square root of 31. Okay? So those 4 things, that's what you got to remember about solving by completing the square. Now, if I wanted to, which we'll go back over probably tomorrow, maybe even on Wednesday, you know, when you're trying to convert between standard form and vertex form, yes, you would complete the square with everything on the same side. Okay, so but when you're solving, you want to make sure your constant's on the other side. A equals 1, then you take half of b squared, add it to both sides, and then factor the left side and go from there. Okay? Let's look at another one. Okay? Is the constant on the side by itself?
Yes.
Is A1.
No.
How do I make A1?
Divide by 2.
And you divide every single thing by 2. So it becomes x squared plus 4x equals 3. Then the next thing. Say, take half of b and square it. 2 squared is. So 4, you add it to both sides. And then what?
Oh, no, add the 2. 70%.
Add the 2 on the right. Yes.
Oh, half of 4. Never mind.
So we add the 2 on the right side, 3 and 4 make. And then what do you do to the left side? Then we finish this off. Square root both sides. There you go. Questions? Next one's on you. All right, here we go. So, constant by itself?
Yep.
A1.
Nope.
So we have to divide by 3. So we have x squared minus 5x equals 2/3. Then we take half of b. b is a negative. And then we square it to get what? 25 over 4, right?
Yep.
So we get x squared minus 5x plus 25 over 4 equals 2/3, 25 over 4. So we factor the left, and just remember, whatever is in this part of the parentheses, whatever you got, we took half of b. It works that way every time. Then over here, we can't add them the way they are. They have to have a what? Common denominator, which is 12. So I have to multiply this first fraction by, and the second one by 3. So you get 8 plus 75, which is, right, is so then we take the square root. You could actually.
Would that be a bit of?
You would leave it as it is. It wouldn't be that. I doubt it would be that nasty from there. I mistyped. I had to mistype. It shouldn't have came out that good.
Should
It's 2. No. Oh, that's why. It's all good. All right, there you go. You guys remember completing the square? Yes, yes? Okay. Last thing, quadratic formula. No need to memorize the formula because, I think, can you confirm this? It is? Yeah, no, you should have it memorized by now, but quadratic formula, what is it? X equals plus or minus square root. There you go. And A, B, and C represent what?
the constants of the problem.
Well, not the constants, because technically there's only one constant.
The
The coefficients. In what form? Standard. So everything has to be on one side, it has to equal 0, okay? Because if you look at the very first one that we have, what's A? B and C. But for this one, A would be what? B would be what? Careful. -3, and C would be what? -7. Because you would have to subtract, that should be a square, not a cube. You would have to subtract 7 over. What I want you guys to do is I want you guys to work on these 3. You solve them using quadratic formula while I talk to Mr. Page. So you should have got when you plugged in, simplify somewhat. -4 plus or minus the square root of 40 over 2. Right? So -4 plus or minus 2 root 10, because this can be simplified down some more. So your final answer is -2. And that's it. You guys get that? Over here, when we got into standard form, the 7 ended up being a negative. So then that is +3 plus or minus the square root. B squared gives us a +9 minus 4 times A times C. Well, that's 8 times a -7, so a -56, right? Over 2A, which is going to be 4, because 2 times 2 is 4. So we have 3 plus or minus the square root of 60 over 4. Can I simplify 65 down? Nope. So that's my final answer. Okay? Questions? So today was supposed to be the day that you had your syllabus signed and turned in all your materials, right? Including note cards? Where's note cards? Okay. Go ahead and pull out a note card. Maybe with your classmates who don't have a note card, if you don't mind loading them one, because okay, when they